Myself, Rajendra Karale. My qualification is MSc Chemistry BA and experience is of 28 years. Now today we are going to discuss about half-life period for zero order chemical reaction which is represented by pH. Now first we will discuss about what is meant by half-life period. Period means time, that is time required to reduce half of the initial concentration of reactant. Period means time, that is time required to reduce half of the initial concentration of the reactant, or it is or time required to complete half of the chemical reaction. That means you can consider any chemical reaction where reactants are converted into product. Suppose initially 1 mole of reactant is there. Out of this 1 mole, half mole of the reactant, that is 0.5 mole of the reactant is converted into product within 5 seconds. That means after 5 seconds, remaining number of moles of reactant are 0.5 mole. Listen here. Consider simple chemical reaction in which reactants are converted into product. Initially, the moles of reactant is 1. Out of this 1 mole, half mole of the reactant is converted into product within 5 seconds. That means here 0.5 mole of reactant remain as it is. That means here concentration of reactant is reduced to half, or half of the chemical reaction is completed within 5 seconds. That means half-life period for this reaction, that is T half, is equal to 5 seconds. That means keep in mind the most important point is that the time required to reduce half of the initial concentration of reactant, or time required to complete half of the chemical reaction. Now here write down expression. Now to find out the expression for half-life period, let us consider here first integrated rate law or integrated rate equation. That means here the expression for integrated rate law for zero order chemical reaction is, that is here K is equal to R0 minus R upon T. Now here that means here T is equal to R0 minus R upon K, equation number 1. That means where T is the time required to reduce the concentration of reactant from R0 to R, K is the rate constant for zero order chemical reaction, R0 is the concentration of reactant at time T is equal to 0, and R is the concentration of reactant after time T. Now when T is equal to T half or capital T, now keep in mind half life period is represented as T half or capital T, then half of the reactant is converted into product. That means here concentration of R is equal to R0. Now this is the initial concentration of reactant. Out of this, half of the reactant is converted into product. That means concentration of reactant at time T half is equal to R0 minus R0 by 2. That means here capital R is equal to R0 by 2. That is here, substitute this condition. In equation 1 we get T is equal to T half. That means here T half or capital T is equal to R0 minus R0 by 2 upon K. That means here T half or capital T is equal to R0 by 2 upon K, that is T half or capital T is equal to R0 upon 2K. This is your equation number 2. That means here half life period for a zero order chemical reaction is directly proportional to the first power of concentration of single reactant inversely proportional to the rate constant. Now T half is equal to R0 upon 2K is the expression for half-life period for zero order chemical reaction. Now write down graphical representation for half-life period of zero order chemical reaction. This topic is only for NEET and JEE. That means this topic is not given in the syllabus of Maharashtra Board of Secondary Education as well as Central Board of Secondary Education. It is given in the reference book. Now here write down the half-life period for zero order chemical reaction is given as, that is here T half is equal to R0 upon 2K. That means here T half is equal to 1 by 2K into R0. Now suppose this is your equation number 1. That means here the graph is obtained by plotting T half and concentration of reactant at time t is equal to 0 is a straight line passing through origin of the time y is equal to mx. Now, by comparing these two equations, this equation and this equation, you can easily find out what is y coordinate, what is x coordinate, and what is the slope of that line. Now here, by comparing these two equations, y coordinate equal to T half or capital T, x coordinate equal to concentration of reactant at time t is equal to 0 and slope which is equal to m and which is equal to 1 by 2k. That means here draw the graph. Here write down T up and here write down concentration of reactant at time t is equal to 0. That means here you will get straight line like this and determine the slope of this line, and here the slope is equal to 1 by 2k. That means here write down figure variation of half-life period with R0 for first order, zero order chemical reaction. Now this is regarding about the half-life period for zero order chemical reaction and their graphical representation. Now here keep in mind the most important point is that the definition of half-life period. Period means time and half means half of the reactant is converted into product. That means half of the chemical reaction is completed. Half of the chemical reaction is completed, and for the completion of half of the chemical reaction or half of the reactant is converted into product, some time is required, and that time is nothing but the half-life period. Now the final equation for the half-life period of zero order reaction, that is T half is equal to R0 upon 2K. Remaining part of this unit will be discussed in the next lecture.